Hello and welcome to another episode of the DigiTeacher. I'd like to continue my series of coding ideas, things you can do in the coding classroom, cool projects that you can do with students. And this week I'd like to look at the MIT App Inventor Platform. So I'll put the link in the description below, but if you haven't used it before, it's a platform that you can get students to create mobile apps. And they can actually download the app and put it on their phones or tablets. So it's quite a motivating project. It results in something far more tangible than most coding projects do. And the platform itself has loads and loads of tutorials with loads and loads of ideas. So this is one of the things that is actually in the tutorials, I think, somewhere on that website. But it's something that you can use when you are looking at working with AI. This is, of course, a really hot topic at the moment. This particular application, you design a mobile app that speaks to Chat GPT, sends a prompt and sends you a response back. So it's a tool for communicating with Chat GPT. And it's a lovely project for a couple of ways. Firstly, it's very engaging for students. They get something really tangible, something which seems really, really advanced, even though the code is fairly simple. And it's something that I think you can really sell to your school administration and to parents. Anything to do with AI is really, really hot. And if you're getting your students to do a project that uses this kind of AI, uses ChatGPT, for example, it's something that I think looks very good on paper. So not only do you learn code, and you learn code to do around designing the interface for the mobile app, to do with text boxes and buttons, the kinds of behavior you get with that, and with speech recognition, and of course connecting to the chatbot. So the chatbot part is kind of the least of the code. It's very simple to use, but I think ticks so many boxes. If you've got this as a project and you can talk about it to parents, they go, wow, this is something beyond anything that they would imagine being able to do themselves. So even though it's quite simple and you're teaching kind of quite basic programming principles, it's something that seems wow, and something you can use in your kind of promo and branding as a hip and happening computer teacher. The use of the words hip and happening, of course, shows exactly that I'm not. But anyway, so let's get down to it. Head over to MIT App Inventor and let's have a look at the code and how it works. Okay, so you head over to MIT App Inventor website and you start a new project. And you have two areas on your screen. You've got a palette here where you choose elements to add to the screen. Your viewer emulates the screen, so it shows the screen how it looks. You've got your components over here, and for example, if I click on that, I can rename it. So that's a button. I've got three buttons: a speak button, a send button, and a read button, and I've named them speak button, send button, and read button. Much better than the default button 1, button 2, button 3. When you come to the coding, you need names which are user-friendly. And you add a button just by dragging it onto the interface. So I've dragged three buttons on, and I've dragged two text boxes on. So the program works like this. When I click speak, I'm going to speak into the app, and it's going to write what I say into this first text box. So it's recognizing my speech and putting it into the text box. When I click send to ChatGPT, it's going to send this, which is essentially my prompt. It's going to send it to ChatGPT, and it returns the text from ChatGPT, its answer, into this second text box. And when I click read, it's going to read the text to me. So that's quite a powerful little function which goes to ChatGPT and returns the results of the prompt into your app. It's got three non-visible components as well. That I find under media, my speech recognizer, and you just drag it onto the screen. And when you do that, it pops up there. I don't need two, so I can just delete that one. And I'm going to need text to speech, so I drag that onto the screen as well. And under experimental, down at the bottom under the experimental palette, you grab chatbot on. And so I've got these three as my non-visible components there. Here under the components, when I click on a component, I can go and change the properties. So for example, the speech button, I've made that red, but I can make it back to its original orange. I can change the size of the button as well. So the font size, if it's ticked, I can make font bold. The height, for example, I can go and fill parent. That would fill, the parent is the screen, so it would fill the whole screen. Or have it set to pixels or percent, or automatic to fit the size of the text. So I've chosen automatic there. I could change the width to fill parent, so then it would fill the whole screen there. So you can play around with that to get what you want. I've made a rounded shape. You could make oval, for example. I just prefer that kind of rounded look. Where it says text, those are the words that appear on the button. So I've clicked speak there, so that's the text that appears. You can align that, change the font color, make it visible or not. So we now have those three buttons and two text boxes. I now need to code that. And to code it, I go into the blocks window over here. So at the top, I'm in Designer, I click on blocks, and I'm in the blocks window. Over here, I've got all my different controls. So for example, control, I can click anywhere here to get the keys, or if I click on the components, I can get code that is attached to that type of component. So if I go to the speak button, then I get the type of code that comes with that. So I can drag when I click. Oh, not when touch up. Get rid of that. I need when clicked. So when the speak button is clicked. I'm also going to click the other buttons. So when the send button is clicked and when the read button is clicked. I need code for all of those. So what happens when I click the speak button? Well, it happens in the text box 1. So I need to get code for that. Well, it must set, initially it must blank it out. So I'm going to go set text box, and it's got background color here. But what I want to change is I want to change the text, and then under text controls over here, I need some blank. So just an empty string. So it clears whatever's there and just sets it to back to blank again. And then in my response text box, I must which is text box 2, I must also clear that. So I'm clearing both text boxes. Come on. No, I need the set one. Now you'll notice I made a mistake there. And when you make a mistake, it's important to kind of model for students. This type of live coding is very powerful because you can model what you're doing with students, your thinking behind it. You can ask them questions, stop them, ask them for advice, get them to come up to the board and find the blocks and put them in. You can do all of that, which is absolutely great. But a very powerful function is making mistakes and how you deal with mistakes. So I made that mistake not on purpose, and cognitive load is a big problem when you're doing this kind of live coding. But you can use that to advantage. I made a mistake, get them to advise you, get the students to tell you how to fix the mistake. So I need, for text box 2, I need to set that. Come on, lock in place. I need to set the text to, and I can duplicate that and pop it in. So when I click speak button, it basically clears it, but then it must call the speech recognizer. So I need to go and call the speech recognizer. So I go to speech recognizer and I need to get the text. So it's when I click the speak button, it clears both text boxes and the speech recognizers gets the text that I'm speaking and stores that. under a speech recognizer, you'll notice there's a when. So after getting text. So after getting text, what must it do? Well, it must set that speak text box text to get the result. You'll notice there's a result there. So I can go and duplicate that first bit of code, but instead of an empty string, it must go and get the result and put the result in there. So I've now got my speak button functions. I can move on to the send button. What happens when I send the button? Well, it must connect to the chatbot. So I need to go down here to the chatbot code, and it must call .converse and give the prompt or the question. So the question will be, well, it'll be that text box text. So that would be in text box 1, and I need to go and get the text. Well, I can get any of these and just change, for example, the height to the text. So it's going to the text box and getting whatever text is typed in there after speech recognition has handled that. So it's now sent the request, it's conversing with the chatbot, and it's getting that that questioning, and when I get the response, so from chatbot, when chatbot has got the response, what must it do? Well, it must set the response text box to whatever I got from the text. So that would be the text box 2. It must go and set text box 2s. It would be more helpful if I'd named them, and I can go and change that now. It must set the text to the response text. Get response text, and plop that in there. And then the read button, it must simply go and read that to me. So that I'll be using text to speech. So when read button text is, it's going to call text to speech, and it's going to speak the message, and the message is going to be the text box text. So I go into that text box, and it's going to take whatever's in text box 2, the text from that, it's going to speak it. So just to go back here, when I click speak, it's going to take speech recognition, put it into text box 1, send. When I click send to Chat GPT, it's going to send that to Chat GPT and return the text into text box 2, and when I click read, it's going to read whatever text is there. So to walk through here, I can get rid of that one, and you'll notice it's not showing any warnings, so the text should be working. So when I click the speak button, it clears both text boxes and it calls up the speech recognizer and gets the text that I speak. And after getting text, it sets text box 1 text to whatever the result is. When I click the send to ChatGPT button, it converses with ChatGPT, so it connects to them using the API, and that's built into MIT App Inventor. You don't have to worry about that. And whatever's in chatbot 1, whatever text is, it questions it, it sends it as a prompt. When it's got the response from the chatbot, then it changes the text in text box 2 to whatever the response was, and when I click the read button, it uses text to speech, it gets the message from text box 2 and speaks that text. So this code should work. How do you test it? Go back into Designer, and over here you can select to AI Companion. And when I click that, you'll notice you get a code. Now, if you go onto Android, into the Play Store, and you download the MIT App Inventor, you would now point it at the screen, get the QR code, or type in that code, and it downloads the program onto your device. So I'm going to do that very quickly just to show you what that looks like. And I'm going to launch the MIT App Inventor program. I point my phone at the screen and I connect with the QR code. It's scanning the QR code, and once it's done that, it's downloading it. So it's downloading it onto my phone. They both need to be connected to the Wi-Fi, and that program is now on my phone and I can test it. So I'm going to speak, and I'm going to set the prompt to, let's say, in 2 sentences, tell me the theory of relativity. So it's now appeared in my text box, and I'm going to go send to Chat GPT, and it's now got a response back, and it's put it in my text box over here. So now when I go read, it will read that to me. I just need to turn there.
Albert Einstein posits that the laws of physics are the same for all non-accelerating observers and that the speed of light in a vacuum is constant for all observers. It also asserts that time and space are intertwined in a 4-dimensional continuum known as spacetime.
Okay, so that's connected to ChatGPT, and it's done all of that. So my program is working, and you can see how powerful it is. Students can create a program in App Inventor and download it onto their phones and use it straight away. If they don't have iPhones, they can use iPads. So with this working, you might have a few little issues to fix, and it's a good idea to get students to kind of add to any project, to take the code essentially they've been given it using the live code pedagogy, but now get them to modify that code in some way. For example, using media to maybe add something, maybe translator, put it into a different language, get them to do something to add to it, even if it's just creating the design here. One thing, this for example doesn't have text wrap, so get them to find text wrap so that the text wraps on the screen. Great program, great functionality, absolutely love it. So that live code pedagogical approach, where you kind of walk through students through how to create the code, and you can ask questions, get them to do it, get them to fill in. It's very flexible. You can have students organized in programming pairs. You can do part of the program, stop it, ask students to find the next step, and then kind of backtrack, get groups to answer back, and allow them to fix their own code. So it's a very flexible pedagogical approach. It does suffer from cognitive load, so it's very easy while you're doing that program to forget where to find the block code, for example, or even what code you're supposed to be using. You just lose track of the program. And that itself offers opportunities for modeling how you think and how you deal with problems. It's also great for modeling debugging. So if you make a mistake and you see the program isn't running, well, where's the mistake? And you can get students to try and spot the mistake and debug the program as well. So I hope you enjoyed this particular episode, and if you haven't yet used App Inventor, please, it's something you really should try. It's great for, I'm a great believer in mixing up the different platforms that you use, so that students aren't just using Scratch the whole time, they aren't just using Microbit the whole time, they're using different platforms. Because then what they're learning is not a particular language or particular set of block code, but what they are using is, what they're learning is the way of thinking. They're learning computational thinking, basically. They're learning to think like a programmer. So if you enjoyed this episode, please subscribe, like, share with your friends and colleagues, and please leave comments in in below. So I'd love to start conversations around what happens in your classroom. What do you do that works? What ideas would you like me to look at? Next week I'll be interviewing Dr. Byron Sherman and getting some of his thoughts on education. So looking forward to that. Bye for now.